So here I'm going to show you a different example. All of the ones that you are looking at today are log base 2 or like natural log, so it's base e. And so here what I want you to think about is what values are going to work here for x. And so if you plug in 1 and 2 and 3 and 4 like you normally would on any other type of function, it doesn't work. It doesn't work as nicely because there's specific values of x here that do work. And so what I want you to think through as you're working through these problems are what values of x are going to work really nicely here. And so if you remember, we have log base 3. And so some values that we have used before are values like 1/3 or log base 3 of 1, or log base 3 of 3, log base 3 of 3 squared, or 9, or 3 cubed for 27. And so these values that we're plugging in are all multiples of 3 that we want to deal with here. So this would be, if we plugged in 1/3 here, what's the exponent for this value? So 3 to what power is equal to 1/3? Well, that would be -1. And then 3 to what power is equal to 1? And that would be 0. And so this right here is kind of your like key point. So anytime what's inside the parentheses here is equal to 1, 3 to what power is equal to 1, it's always 0. And so this is kind of your like your y-intercept, or your x-intercept, excuse me, your x-intercept, and so it's where you're crossing that axis, and that's kind of your like, can I find this point? Then I'm good. And so then we can fill in the rest of this here. So log base 3 of 3, 3 to what power is equal to 3, that's going to be 1. And so these are all my x values here that I'm plugging in. And so then I could plug in 9, or I could plug in 27. So 3 to what power gives me 9, that'd be squared. 3 to what power gives me 27, and that would be 3. So when I go to graph this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so I have a point at 1, 0. I have a point at 3, 1, because it's the first power. And then here, 9, 2. And then if we want to, we can plug in this value as well at 1/3. That's -1. And so what's happening here is I'm never going to go negative. So what's in my logs can never be negative. But then I'm going to go through each of these points. And there is our basic shape of our graph. But here I'd have, I'll use a different color. Here I have a vertical asymptote. So we just talked about asymptotes with rational functions. This one also has a vertical asymptote because I cannot cross and be negative unless I've taken and shifted my graph left or right somewhere. So here's my vertical asymptote, and then some points and my curve that's going through those. So hopefully that helps as you're working through some of these log problems and trying to graph them.